Okay, now we are going to use one of the window binary called Crackme to illustrate how uh, we are going to use the disassembler and debugger. And inside the debugger, we can check how the stack base pointer and the stack pointer and also the calling function, how they are working on with the argument pushing from the caller function to the call function. So let's first see the basic structure of the Crackme program. It is a C program. Right now you see the source code. So it first define one global variable called password, 1, 2, 3, 4, 5, 6, 7, and then go to the main function. And the first part of the main function, it initialize an integer variable called valid fact with the initial function value of 0, and declare a another dynamic variable called password with the size of 1024. And then it creates a continuous loop until it breaks and print out a message called please input password. And then calling another function, C library function, to collect the user response from the keyboard and put it inside the temporary variable called password, and then push this variable to the call function or a subroutine called verify password, and then get back the response from the value of verify, whether it is true or untrue or 0 or not 0. So when you push the password, for example, the input password is 1234, it will collect the 1234 address pointer to the variable 1234. It treat it as character and check whether it is authenticated or not. It declare another return value of the integer, and then perform a string comparison function by the global variable and the import temporary variable. If that is okay, it will return either 1 or 0 or 0 or any value. Once it is confirmed is if that is correct, that is if that is not correct, it will print out incorrect password. Else, it will say congratulations, you have passed the verification. So by using this Crackme program, we can perform some preliminary review of PE file and check the string character contained inside. You can find the API call in the C library, such as printf, scanf, stringcom. And then we are not able to see the variable name because we are not having the symbol file provided together. And then we can, by using this simple C program, we can see the while loop as well as the if statement. So right now I'm going to use the bean text and the one of the PEID, std_id, or CFF Explorer to check the PE file. Let us go to the Windows virtual machine. Okay, we have a Windows virtual machine displayed on the screen right now. First of all, I need to dig out the Crackme or crack sample. The sample is put inside the samples folder. Inside Crackme zip, you can find now two versions of the Crackme. I drag out the Crackme program. This cracked is another function that we are going to display to you and show you how we can patch this binary so that we can bypass the verified input function, but we are not covering by this video. So first of all, we can drag this to PID or drag to step P, but I prefer to use the CFF Explorer. You can check the P header, and also you can see the timestamp. In the optional header, you can see some interesting thing you need to remember at this moment. First, you need to check the email page address. That is at this 400000. Right here, this is the first instruction code, first byte of the code section to be loaded into virtual memory. Another is the address of an entry point. The first byte of instruction of loading of this code section is at 1298. This is the first byte of P file load in 40000. So by adding these two together, that is the virtual memory address of the entry point. Let's move this to the bin test to check what we can find. Okay, you can find the doorstop. You can also be able to find these interesting commands such as the congratulation and the global variable password, and then another command from incorrect password, please input password. If we set up different location inside this binary location in the debugger as breakpoint, we may be able to find how we can follow how the CPU instruction, and we can follow what changes in the stack location. So we can close this program. Now, before we are going to use the Win debugger and IDA Pro, I need to give you some basic introduction. What is this disassembler and debugger, how they are function by a few slides. Okay, we go over this debugger and disassembler function slide very quickly, only for our sufficient knowledge to handle this video demonstration. We will cover the debugger and disassembler functionality in more details. Basically, debugger, what is a debugger? A debugger is we can making use of the debugger to set the breakpoint and then trace through the code. And debugger is a process. You can treat it as the grandparent process. When a binary is executed, it is we can use a debugger get hold of it, or we can put using the debugger to load a new PE file and then start up another section of the process and then control the newly created process under the control of the debugger. OllyDbg is one of my favorite GUI interface debugger, and basically it comes with it is some kind of ring-free user mode debugger. It comes in different kind of function. You can remember this key, but a couple of them I'm using quite a lot, such as run, let it run continuously, run inside and under the control of the debugger until it hit the exit or until it hit the breakpoint, and the debugger will stop the process of the debuggy program. So Another one is called the step over. I use a lot. And one is called step into, that we go inside the function. And if you hit plus and minus, you can go into the function instead running into the function. And if you want to go back, you hit escape. If you want to change the location view to a particular address, you hit Control G. So we have four major pane in the debugger. One is the code section. If we load everything, every binary inside the debugger, it will stop at the entry point. Remember, the entry point is the base address plus the image entry or entry point. So we have register CPU pane, we have memory dump pane, and we have the step pane. Usually we need to use our eye to monitor these 3 or 4, 5 area. Sometimes you can see some helpful information from the message pane, but the CPU pane is more important, and then whenever you see some changes in the register after it changes, turn into red, we usually pay more attention on the CPU pane and the step pane. So you can see some other function of the debugging program. Okay, we go to check with what is disassembler. In our demonstration, we use IDA Pro, which is a disassembler. Unlike the debugger actually is kickstart a process, but the disassembler is just inspect the binary, the PE file or the image file statically without running the binary. But it will do more other than string or the basic code check tools such like the PE Explorer or the PEID. It will scan through all the code and display you more information and analyze which is the possible function and display it in a nicely presented GUI interface of the which functional chart. By using the views, you need to access a couple of the view when you're performing with the disassembly by using the IDA Pro. One of the IDA Pro view, that is the graphical user interface. You can see a block of code, and then when you hit the space bar, you can go to the exit view. You can see where is the RVA of the particular function or particular instruction code. And then the name view is the important function, and the function view can find the main function or start function. Some simple keys similar to the debugger. For example, when you control minus or control plus, you can zoom and unzoom, because when you're using IDA Pro, you need to have a large screen, but you don't have, you need to minimize it or zoom in or unzoom it. Control X is important to check the control reference, but we are not covering right now. And then you can hit G, you can go to a particular location. The key similar like debugger, but they are not exactly the same. Okay, so that is the function of the debugger. Right here, I would like to insert one more thing. When you load the binary inside the debugger is actually create a new process below it and put it the control and stop at the entry point. The entry point is made up by the entry point address RVA contained inside the PE header plus the image base address. In our example, it will stop at the 4010 40. That is the entry point of the debugger. But in the disassembler, such like the IDA Pro, they will provide you some function. It skip you to the start address and directly put you into the main function. What is the function? What is the code running in between the start and the main? Because when every window binary, when they kickstart, the compiler and linker will create some configuration code which is not which is only used by the Windows binary or Windows system to allow the binary can run into a more efficient manner. That section of code we don't need to analyze. So when you put the image file or binary inside the IDA Pro, we just put you the concentration to the main instead of the start. So I will show you later on once we perform the demonstration on using this tool. So we will cover, we visit this section again when we go to the module 6. Okay, we go back to the virtual machine. So we drag out the Crackme program, and for example, if we want to put the PID, it will give you more information about the entry point. The entry point is addressed at the RVA of 1298, 1298. That is the entry point. And then you can also use the subsystem, and you can see the import table, what is calling by kernel 32 DLL.dll. Let us run the Crackme inside to check what is its function. We open a command prompt. Before I drag the Crackme from the sample to my desktop, I create another copy of the Crackme and put it inside the tool folder. So I go to the tools folder and check what is contained inside. You can find that there is Crackme inside here. Let us run the Crack program. First, it will give you please input the password. For example, right here, I type 1234, and then hit enter because it is not equal to the global variable of 1234567. So it gives me an incorrect password. The verify password call function finish and provide you back an error and return back to the call main function. The main function is the call function, and then it run into a loop and asks us to provide another try until we find the correct answer. Right now, I type in everything so that you can see that that is the correct information that I can provide to the Crackme. That is the correct password. And then I can get this response message. Now I don't need to see this program, but I would like to drag this to the disassembler, the IDA Pro program. When you start the IDA Pro program the first time, you need to click OK. You accept all the default function. You don't need to change it any of them for all of our sample provided to you. When we're using IDA Pro, basically we need a very large monitor, but we don't have. I have some tricks to help you to using a small window. When I am talking, you will see something is moving right here because IDA Pro is analyze the code section item by item and try to give you some of the meaningful analysis of the code. Once it finished, it will go to display you IDA view. If you want to more efficient use your screen, you need to use my trick. Try to enlarge the IDA view first, then and one of the empty space, you hit Control right click, and then you select the main. And usually you don't need to see many information about the message. I usually keep one line on that, and IDA Pro will provide you a small overview diagram. That is the way I usually handle my IDA Pro section. And also, if you want to zoom it and unzoom it, I hit the controller using my mouse. You will see my mouse icon have a plus sign on below. So if I'm moving my mouse wheel, you will be able to zoom and unzoom your screen. And then I try to go to the function view, and I can find start and main. What is the start address? The start address is 401298. That is same address of the PID showing in the base address, base image address plus the entry point. That is our VA. Add up together and we have the VA, virtual memory address. And the main is the main function location as 1040. If we want to go back to the IDA Pro and go to the main, it first display you the main instead of display to you to the start. And if we hit spacebar, you will see it will stop the main addresses stop at 1040 instead of it stop at the address of entry point at start called 1298. So can we go to 1298? Yes, we double click here. It will go back to the original entry point of this binary when it's execute the first byte. I try to zoom it in. You will see some of the functions. We don't need to analyze this. This is configuration function to allow this Crackme program to run. And then after it configures everything, it will go to the main program, make a call. And the call, if I double click it, it goes back to the main function. Okay, that is IDA Pro. And if you click on call, and you will see all the call function that be highlighted. We don't need to analyze PNF. We don't need to analyze the scanf. And here is the variable push to the pin. And then it performs some function. That is the loop of the while loop continues running. You will see one call E function inside the main function. That is at the address 401000. If you double click here, it will IDA Pro will give you the function section. And you will see here that is the if else looping to confirm everything and return by checking the global variable 1, 2, 3, 4, 5, 6, 7. And whenever item by item, character by character checking, it will perform the function to do the comparison and then return back to the calling function. If I want to go back to the calling function, I hit escape. So bear in mind, the IDA Pro is disassembler. It helps you to analyze the program that to be run. It will not create a dynamic version or running version of this process, but debugger is on the difference. Okay, so that is the reason I want to show you the disassembler first. Now I minimize the disassembler and without closing it, because when we perform behavioral analysis, it's simple, but when we perform the code analysis or static analysis, we need to use these tools interactively. Now we drag the create a Crackme program to one of the my favorite Windows version debugger called WinDebugger. When you start the WinDebugger, as I illustrate previously, you need to familiar how to use the the OllyDbg. So you find the CPU pane and expand it. Right now you have 4 panes: CPU pane, register pane, the stack pane, and the dump and the message. Before we start anything, we check the entry point. It stopped at the entry point of 1298. That is the first byte of the code section. 40 means the image base address. When image base address add up with the image entry point, it will give you the VA virtual address of the entry point at the address 401298. It is not the main program because all the code running between the main program at 401040 and the 1298, they are some configuration function performed by the only facilitate Windows OS to run the binary. We don't need to analyze this section of code between 1298 and the main. So let us go to one of the view called the breakpoint. I need to check, depends on how many times you use the Crackme program inside IDA Pro. IDA Pro may keep some previously configured information inside the IDA Pro program. So I need to double check the breakpoint screen. Right now, I only have one. If you have some more other, you need to remove it. I set up the entry point or one of the breakpoint at the location of 1040. So if I double click it, it will go directly go to the location. How to set a breakpoint? When we click here and just like turning on and off a electric button. Okay, 1040 is important. We need to analyze. We don't need to see that. Now we need to check other function. For example, we need to check some meaningful reply that we can get from the screen. So we need to check the string of these PE binary. How to perform a string check in the OllyDbg? I right-click it and go to search for or reference string. This string will give this window, this pane will display you the all the string identified by OllyDbg. So now we see the first command is the piece input password. So how about I go to this location and then, okay, this is the next instruction after the main function first address. Now we go to the string function again, search for all reference string, and then we believe the one of the key function to handle verification of the code is at the address of 40100, but we don't find this here. If we don't have the disassembler, we don't know where's the call E function to verify the content that we provide. But one thing is we must be able to find the function returned from the incorrect password. Before this, you will see from the start of the main function, it runs this code. And then there is a call right here. And that is a call here. And pay attention to the call or jump. I don't know what is it, but clearly this is interesting. We need to see. If we want to see what is contained inside, bear in mind right now I'm in a running version of the Crackme. I'm not running it right now, but I just want to see anything happen in this function. I can double click it and then can see something like this. And if I put this my icon right here, I hit enter, I will go inside the function. You see 40100 is important because it do some activity right here. So how about we set up another breakpoint right here? Then if we want to go back to our debugger or the debugger held instruction, we hit escape until we find the location that is highlighted in black. That is the beginning that the instruction pointer is pulled. Okay, right now I let the program run. So it will stop at the first breakpoint. That is my intention. This is the start of the main function. And you will see that it performs some function to go to, for example, it changes this base pointer address by adding, by increasing the size of 400. Why 400? Because you remember to the code section. Let me go back to the source code. Here we go back to the source code. You see there inside this main function, after declaring the one of the integer variable, it declare another array of size 1 to 1024. Yeah, what is this? Is decimal number. What is the hexadecimal number? 1210 the 1024. If it changes in decimal, it's 400. Let us go back to our virtual machine. Sorry, I forgot to change my screen. The screen should show here. It declares variable with 1024. In hexadecimal is 400. Now we go back to our main function. It will increase the stack pointer size with 1024 byte. As we have discussed previously, the stack is on the opposite side when it moving when you increase the stack size. Actually, it's perform mining. It perform in a reverse way. So when you see subtract of the base stack pointer, meaning it is adding some more empty space and then put in the function. Right now, for example, if I execute one function, you will see that the stack pointer size right here is at 14FF34. It will, if I go one step, it will minus this address with 400. Here, that is a go step into, that is step over. We execute one CPU instruction, that is we are using step over unless we want to go into it. You see the step pointer just changing by minus 400, and the content you see difference. Now we go to the feature that we let it run until the location pointer. If you hit this, and it will not stop at the call function called verify password. and you will only see running right here. What happened actually? Why the debugger will not stop at the breakpoint? Let us minimize the OllyDbg, because inside OllyDbg, it create another command prompt to run this Crackme, and it is awaiting the user interaction. So it is keep on running. So this time, let me type 1, 2, 3, 4, and then I hit enter, and you won't see anything come out, just like before the example that I run without the debugger. I should be able to find something, but it is not coming out, all because the OllyDbg stop at some location awaiting we to check. So we expanding the OllyDbg again. You will see that something coming in here. If we go this one by one, we may see some interesting comparison, and then it will go to do some checking. For example, we step one by one, and you will see the information of user interaction with the scanf function. It push, it keep the new value into here, and then it will try to make some comparison with the global variable. Okay, so there you can see that it will go to another loop to try to compare this value and this value, and it will compile byte by byte until it finish. Right here, because I type 4 item, it will compare 4. The loop will go to 4 times and then go back. And if we keep running, and you will see running. Why is running? Because something coming out from the Windows terminal. And then it will say incorrect password, and then you can type something this time. If I type correct, and if I go back to the Win debugger, it stopped before the comparison. How about we do something more interesting, and we can go to go back a little bit by hitting the escape. I go to, okay, how about I just go to hit, go to the 1400, and then we cause 40100, and then we keep a breakpoint right here and check what is happening. So I hit run. You will see that that is a 0 right here as a return value from calling in 40100, and then we hit the next instruction. You will see there is some comparison of the EAX register, and then it will bypassing, not go into the incorrect, because I already typed the correct value. And then hit one more, and you will see that it will call a push one value to the stack. Right here, the stack has nothing. You will see this content pushed to the stack, and it will call a function. We don't need to analyze this function because it seems to push something onto the screen. And then we push one more, and then minimize it, see whether we can find this in the window terminal. Yes, it just coming out this. And then we'll go by do some other things, and it will do and return. It will return to the main function. And after it finishes everything, it will terminate the program. So you see the program is terminated.